Assalamualaikum warahmatullahi wabarakatuh. I, AINA FADHLINA bin SHAMSUL, metrik nama D2018-108-3399. I would like to present for part B, number 1. For question 1, find and modify an application problems that can be formulated as a linear programming LP problem with at least 3 decision variable and 3 constraints. The question is, consider a cake manufacturing company that produce only 3 types of cake, which is A, B, and C. All the cake require flavor, flour, and egg only. To manufacture each unit of A, B, and C, the following quantities are required. Each unit of A requires 1 unit of flavor, 1 unit of flour, and 2 units of egg. Each unit for B requires 2 units of flavor, 3 units of flour, and 3 units of egg. And each unit of C requires 1 unit of flavor, 2 units of flour, and 4 units of egg. The company kitchen has a total of 5 units of flavor, 10 units of flour, and 10 units of egg. On each sold, the company made a profit of 4 ringgits per unit A sold, 5 ringgits per unit B sold, and 6 ringgit per unit C sold. Now the company wishes to maximize its profits. How many units of A, B, and C should it produce respectively? First, in the chapter 2, we already learned about the LP problem. To solve the LP problem, we have to know these 4 steps, which is for step 1 is decision variable, for step 2 objective function, for step 3 constraints, and the last step is optimization model. Okay, here for the step 1 decision variable is x1 equal to total units of A produced, x2 equal to total units of B produced, and x3 equal to total units of C produced. And for the objective function, for the optimization model, maximize Z equal to 4x1 plus 5x2 plus 6x3 x30, x1 plus x2 plus 2x3 smaller and equal to 5. And the second constraint is 2x1 plus 3x2 plus 3x3 smaller and equal to 10. And the third constraint is x1 plus 2x2 plus 4x3 smaller and equal to 15. And the last constraint is x1, x2, and x3 bigger and equal to 0.
Hello everyone and good day. So today I'm going to show how to solve an LP model using a Lingo solver. So let's to begin with, let us consider this question. So in this question, it says that consider a cake manufacturing company that produces only 3 types of cake, which are A, B, and C. All the cake require flavor, flour, and egg only. To manufacture each unit of A, B, and C, the following quantities are required. Each unit of A requires 1 unit of flavor, 1 unit of flour, and 2 units of eggs. Each unit of B requires 2 units of flavor, 3 units of flour, and 3 units of eggs. Each unit of C requires 1 unit of flavor, 2 units of flour, and 4 units of eggs. The company kitchen has a total of 5 units of flavor, 10 units of flour, and 15 units of eggs. On each sold, the company makes a profit of 4 ringgit per unit of cake A sold, 5 ringgit per unit cake B sold, and 6 ringgit per unit cake C sold. And then the company wishes to maximize its profit. How many units of A, B, and C should it produce respectively? So here is the solution. So to make it easier for us to formulate the LP model, let us take out all the information and then put it in a table. And then after that, we can get the LP model for this question. After we got the LP model for this question, we simply plug in the LP model into the Lingo solver. And then we will get here. So this is the LP model that I have keyed in into the Lingo solver. And then to find the answer, I simply click on solve here, or I can click on right click and then click on solve. Close this one, and then there you go. You have your solution. So from here, the objective value is the Z value. So we can see here that the company can maximize its profit to Rm25 ringgit. So from here, there is X1 variable, which represent the number of units of cake A, and X2, which represents the number of units of cake B, and X3, which represent the number of units of cake C. And from here we can see that to maximize its profit, the company needs to sold 2.5 units of cake A and 2.5 units of cake C. To find the ranges for sensitivity analysis, we simply click on solver and then on range, and here we are. We have the range for us to do the sensitivity analysis. For example, row 2, which is the first constraint, the current right hand side value is 5, and we can increase the value as much as 2.5, and we can only decrease its value as much as 1.25.
Now I'm gonna explain the answer for question 3 part A. For this part, we were asked to discuss the sensitivity analysis of our application problem in details by giving an example when there are changes on the right hand side. In the first Roman, all conditions are feasible. Based on the answer of question 2, we provide 3 feasibility range for each condition. For D1, the feasibility range is less than or equal to 2.5 and greater than or equal to negative 1.25. For D2, the feasibility range is less than or equal to positive infinity and greater than or equal to negative 2.50. For the last condition, which is D3, the feasibility range is less than or equal to 5.00 and greater than or equal to negative 5.0. The right hand side or RHS changes are D1 is equal to 2, D2 is equal to negative 1, and D3 is equal to 2. Based on previous learning, a solution will be feasible if the RHS changes are within the feasibility range. Then, supposedly all conditions are feasible. Clearly, we see that all RHS changes are between the feasibility range. Therefore, we can say that all RHS changes of each constraint is within the feasibility range respectively. Then, all conditions are feasible. Hence, the current basic solution will remain feasible. In the second Roman, at least one of the conditions is infeasible. As provided below, the RHS changes are D1 is equal to 10, D2 is equal to -1, and D3 is equal to 2. With compared to the RHS changes of the first Roman, the only difference is the value of D1. For this part, D1 is equal to 10, and obviously we can see that it violates the feasibility range, which is D1 is less than or equal to 2.5 and greater than or equal to -1.25. As we know that a solution will no longer feasible if the changes is not within the individual range. So, the condition for this problem will be infeasible. Thus, the current basic solution is no longer feasible. That's all for this part. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So my name is Aidil So I will discuss about question in part B, 3B, Roman 1. So we're gonna discuss the sensitivity analysis, which when there are changes in the objective function coefficient, when there are changes in the objective coefficient, where the condition are satisfied. So, if you for to answer this analysis, we will refer to Lindo table at objective coefficient range. So this is our optimal solution in Lindo software. So in variable x1, x2, and x3, the allowable increase is 2 and allowable decrease is -0.1. For variable x2, they are negative infinity to 2. For variable x3, -2 and 2. Then we can say that the optimality range for x1 is -0.8 to 2. For coefficient x2, negative infinity to 2, and coefficient x3 is -2 until 2. Then when the objective function coefficient change to d1, d2, or d3 is at -1, the change of objective function is still within the optimality range. As we see, the d1 for d1, the coefficient for x1, you can see the one is still in optimality range. Thus, the optimal solution still be optimal. Then we can say that total profit will increase. They will change in the objective function coefficient. For example, for cake A, per unit production, we change the production increase or decrease by 1 per RM, 2.5 ringgit. So we can see when we change the production by 1 in coefficient for production cake A that represent coefficient x1, then we can see the new profit for this optimal solution are 27.5% for the new profit. Okay, now we move to the 3B Roman 2. When the condition is unsatisfied. As we see, this is the optimality range for coefficient x1, x2, and x3. So to make the condition unsatisfied, we change the objective coefficient for x1, x2, x3 such out of the optimality range. For D1, we say that the production is 3. For D2, coefficient x2. For D3, coefficient x3 is 5. Then the change of objective function is outside the optimality range. This show that the changes will not keep the current solution. So I hope you understand, and that's all from us. Thank you.